I remember back in the early 1980s when I first started learning networking and I'd studied the OSI reference model. I was pleased as punch when I would read an article and it would talk about the application layer services of XYZ, or something at layer 3, or a new layer 2 device, because I knew the functionality of those OSI reference model layers, and I thought to myself, okay, great, that kind of gives me an idea of what that product or service does. But then it also occurred to me, pretty much at the same time, that we would be hard-pressed to find a computer that's actually running any type of an OSI reference model protocol, because the OSI reference model is just that. It's a reference model. It's not a common real protocol that we're using today. So I thought to myself, what are we using? Well, back in the day, we had lots of other protocols, including IPX, but we also had this new and upcoming protocol called TCP/IP. And TCP/IP was courtesy of the government. The Department of Defense created it. And this TCP/IP was actually a literal protocol stack, a suite of protocols working together to provide the functionalities that were described as part of the OSI reference model. And so if we put them side by side here, all the functionality in the OSI reference model regarding layers 7, 6, and 5, the application layer with network services, the presentation layer dealing with encryption and decryption and compression, and the session layer dealing with the establishment and the setup of sessions, all that functionality can be found in the TCP/IP protocol suite in the one layer called the application layer. And then layer 4, the transport layer of the OSI reference model, we usually refer to that as the transport layer here as well in the TCP/IP protocol suite. Also, it's sometimes referred to as the host-to-host layer. In either case, it's providing the middle manager functionality for reliable or unreliable delivery based on the application we're using, as well as the potential for chunking up large messages into smaller parcels or pieces. But the functionality from the model and the TCP/IP protocol suite are the same at that layer. And then as we go down to the network layer of the OSI reference model, in the TCP/IP protocol suite is referred to as the internet layer. However, the responsibilities and functions are the same as the OSI reference models, which include adding address information, like for example, a street name and a house number, or in the case of the TCP/IP protocol suite, it would be a logical IP address, which we can think of as a house number and street name that allows a packet to be delivered over a network to the device it was intended to go to. And then as we continue to go down the TCP/IP protocol stack, we have this one section called network access, which includes the functionality of the data link layer and the physical layer of the OSI reference model, which would be our envelope stuffer and the correct framing for the messages and the actual physical transmission and sending of the information over the network itself. But there was one more challenge I discovered, and that was, well, if we're using the TCP/IP protocol suite and I'm reading this article and it's talking about a layer 2 device, how does that fit in? And so for the actual practical purposes, for you and I as we work with TCP/IP networks, which is the major protocol in the world today, when we refer to the actual names and layers, for layer purposes, we're going to borrow the names of physical and data link for layers 1 and 2, even though we're actually using TCP/IP. And one of the benefits of that, it allows us to be very specific when we're talking about components. For example, if we get a new network adapter and we plug it into a computer and it's physically connecting us to the rest of the network, we could say that that network adapter for that purpose is a layer 1 device. It's a physical layer device. Also for TCP/IP at layer 3, we refer to layer 3 as the network layer. So we're leveraging the name from the OSI reference model, actually renaming the TCP/IP protocol suite, the original name for that layer 3, which was internet, and simply calling it once again network. And also at layer 4, we're hanging onto the name of transport as the transport layer in the TCP/IP protocol suite. And then for everything above that, which would be layers 5, 6, and 7 from the OSI reference model, we just refer to that one big chunk of functions and features as the application layer. So as we discuss the actual use of a protocol stack, and going back to our analogy with our King A and King B, or a user like Bob sitting in front of a browser, to access the network services, those are being provided by the application layer of our TCP/IP protocol stack. And as that information is passed down this protocol stack, and each of the responsible parties are doing their work and this being sent over the network, we can use more specific terms for the data. For example, if we had the middle manager, the transport layer, that was currently working with or looking at some data, instead of calling that data, we could refer to that information at that layer as a segment. For example, a segment of data. And as that information gets passed down to the mailroom, down to the network layer at layer 3, we could refer to the data at that layer as packets. And as the network layer passes that down to the envelope stuffers, the data link layer, we could refer to the data at that layer, layer 2, as frames of data. And then as that information is actually transmitted or sent, the actual data could be referred to as individual bits that are being sent over the network at that point. So the question might come up, well, Keith, does that mean that anybody who says the word packet always is talking specifically about layer 3 of the TCP/IP protocol suite? And the answer is no. Because some people use terms loosely, and we might have to take things in context. But the beautiful thing is this, you and I going forward, if we say segment versus packet versus frame, because we know these terms, we can assume that if one of us says the word segment of data, we're referring to the data here at layer 4 of the TCP/IP protocol suite. And following that logic, if you and I were to talk about frames, we would be referring to data at layer 2 of the protocol stack. I hope this has been informative for you, and I'd like to thank you for viewing.
Can anybody out there